Okay, welcome back. In the previous video, we talked about what it meant for an infinite series to converge. What it meant for an infinite series to converge. And we will be looking in upcoming sections throughout this chapter at different ways to check on the convergence of an infinite series. So we'll be able to decide if it converges. Now, we will be kind of limited, though, on infinite series actually figuring out what it converges to. And that's going to be something that we're actually going to be a little limited on. So what we're actually going to take a look at now are two categories of infinite series that we can actually pretty easily figure out not only does it converge, but also what it will converge to. So those are going to be called geometric series and telescoping series. So we're going to describe and introduce this idea of a geometric series because this is going to be one where we're actually going to be able to talk about what this series converges to, and also, of course, whether it actually converges. So a geometric series is a series that's based off the underlying sequence a sub n equals a times r to the n minus 1. Remember, we talked about the geometric sequence already, right? We previously talked about the geometric sequence, right? So geometric series is going to be adding up the terms. Now, we use a slightly modified version of this now when we talk about geometric series. So previously an was a r to the n. Now we're actually going to make it a r to the n minus 1. And there's reasons for that. That'll kind of become a little more clear when we start looking at what this series looks like. So the underlying sequence is just a sub n. In that sequence, the first few terms would be a, then ar, then ar squared, ar cubed, and so on. Okay? So the partial sums will look like this. Partial sums, as we start adding them up, terms, the partial sums, sum s sub n would be a plus ar plus ar squared, and so on until we got to ar to the n minus 1. Okay? Ar to the n minus 1. Okay? So what we do now is we can write that as a summation. So we're going to do it this way. Now we could say n goes from 1, or I or whatever goes from 1 to n. But we actually are going to describe this starting with 0, just because it looks a little nicer. So we're going to go sum going from 0 to n minus 1 of a times r to the k. So when k is 0, that would just be a times r to the 0. Right? A times r to the 0, so just a. K equals 1, that would be a r to the first. K equals 2, ar squared. K equals 3, ar cubed, and so forth. So I'm going to take that thing and I'm going to label that as formula 1. Okay. We're then going to take formula 1 and we're going to multiply it by So that's going to get us the second formula, R S sub n, which would be AR plus AR squared plus AR cubed, and so on and so on. So the last one gets multiplied by R, which would just be A plus AR to the n. So this we could describe as the sum as k goes from 0 still to n minus 1 of A times R to the k plus 1. Right? So at 0, k plus 1 would be 1. At 1, it would be 2, and so on. And we're going to call that formula 2. Okay. And then what we're going to do now, we have these two things, is we're going to subtract 2 from 1. Subtract formula 2 from formula 1. Okay. So what I want you to see is what happens when we do that. Well, on the left-hand side of my formula, I'll have Sn minus Rsn. S sub n minus R S sub n. Okay? On the right-hand side, well, here's what I want you to notice. Here's what I want you to notice. When we subtract 2, so we take formula 1, and we do minus formula 2, I want you to notice that a lot of things go away. A lot of things go away. So first we have A. There's no single, just A term down here, so that stays put. Then we have A times R minus A times R. So those ones go away. Okay. We then have AR squared minus AR squared. Right? And that one will go away. Okay. Then the next term, the one I didn't write out here, would have been AR cubed. Well, that AR cubed is going to cancel with its part. So with the one that would have been sitting right around there. And then we continue all the way up until we get to AR n minus 1, which is the last one there. And that's going to cancel with the one that happened right before AR to the n. So all that's left when we get done is just the A from the original one, and then minus the AR to the n from the second one. Okay. And now we can actually solve this thing to get a formula for S sub n. That's the whole purpose of doing all this setup, right? Was to find a way to actually get a formula for the partial sums. Something that's a little easier than having to write out this whole sum. To get a formula for the partial sums. Because now what we can do on the left-hand side of our formula is we can factor out an S sub n. And that'll be times 1 minus R equals A times 1 minus R to the n. And so the sequence of the partial sums will now be, we divide by that, and we get A equals 1 minus R to the n over 1 minus R. Okay. So now we have a formula for the partial sums. Now we have a formula for the partial sums. And so we can use that now, to compute whatever sum we want, as far as we want to go. Okay. Now, very important here when we talk about this geometric series, our sum based on the math and everything that we've set up here, right? The math that we've set up here, our sums are going from 0, right, to n minus 1, right? 0 to n minus 1. That's S sub n. S sub n goes from 0 to n minus 1. Okay, so it's very important that you keep that idea in mind. A lot of times when we do sums or series, we will have them start at 1. But for the geometric series, right, it's going from 0 to 1 less than whatever we're dealing with here. So that's an important idea that's going to come up as we continue on here. Okay? So we're going to now look at computing some geometric sums. Okay, and then we'll turn to series. We'll turn to the infinite series. But first we want to look at some geometric sums first. Okay, and now we have a formula for geometric sums. Right. That Sn, which again is the sum as k goes from 0 to n minus 1 of a r to the k. We now have a formula to compute the sums. And there it is, a times 1 minus r to the n over 1 minus r.